Okay, to find the force, draw a little diagram of the question. We got a normal force going up here because it's a pillar. We got a normal force going up here because that's a pillar. We got a force going down because of the person, and then we find the pivot point. I mean, well, the midpoint or the center point, center mass of the bridge right here. So to find the forces of that, it's pretty much mg. Yeah, mass times gravity. So 638 newtons, and then for the board, it's 147 newtons. Now we say that well, first let's go right here. Well, now let's go torque. The torque net is equal to 0. We get that by saying, well, we get this right here by saying the clockwise. Well, we pick a pivot point first. This is our pivot point. We click, well, pick our pivot point, and then the clockwise will be positive, and the negatives is going to be counterclockwise. So around this pivot point, Fn is going clockwise. So we put it right there. Force of the person is going clockwise. So we put it right there. And that's going to equal this one right here because it's going counterclockwise. So it's negative. So you could say that minus torque N2 equals 0, but we just bring it over, so we just said that. Alright. So now we go to the F net, the forces. So we play all the bottoms equal to the top. So the force of the person plus the force of the board is equal to the force, normal force, and the force of normal force 2. So let me put a line right there because that doesn't. So we say that, and to get that, well, let me arrange this. So that right there and that right there, we have two equations. We need to pick a new pivot point because we can get one to cancel out. So let's move down here and say this is the new pivot point. That means this is going to cancel out because it's a 0 radius. So anything times 0 is 0. So now we say that the torque net is equal to 0. We say that Fn is going clockwise. So we put we put that Fn is equal to these right here because it's going to make it going counterclockwise. So let me just rearrange this and put torque of the board plus torque of the person is equal to the torque of the normal force of 1. So now let's put it all in. Fg board times the radius of the board plus Fg of the person times the radius of the person is equal to the force of N1 times the radius of N1. Okay? So the force of the person, of the board, is 638. Alright. Now let me see the force of... Okay, it's force of the board. It's supposed to be... Well, it's supposed to be 1... Okay, I just got it mixed up. Let's say this is the force of the person. It's 638 newtons times 4, which is the radius, plus 147 newtons of the force, that's the force of the board, times 2, which is the radius of the board, equals the Fn times 8. Okay? So that's going to equal to the Fn1 is equal to 366 newtons. 356 newtons. So once we found Fn, this one, I mean Fn of the normal force of 1 is 356 newtons, we come up here and we plug it in for right here. So 638 plus 147 equals 656 plus the force of N2. So we just take that, well, we take that and subtract it from that. Okay, so we take 638 newtons plus 147 minus 356 equals N2. So that's going to equal to 429 newtons. So the force of, the normal force of 2, is right here, or right here, is, is 429 newtons. So that's how we find the normal forces of this stand.